So with this question, the first thing that you should take note of is that the quantity of electricity that was supplied in both cells is the same. So the quantity of electricity, and the other thing is that the period of time is the same in both cases. So what is the quantity of electricity? Okay, the quantity of electricity is actually current, and when they talk of time and current, they basically mean charge. Okay, so in other words, what they're saying is that in both cases the charge was the same. Okay, so having that, what should we think of? So let's say Q in the case of AG is equal to Q in the case of AU. So basically this is what they mean. So having said this, what is Q? Q is equal to the quantity of N multiplied by F. Okay, N multiplied by an F. N meaning the number of moles and F meaning the Faraday's constant. So basically this N is not necessarily the number of moles of AU or AG, but this is the number of moles of electrons. So how do we find those? So for AG, we know that it's AG plus actually. So we know that it has only one electron that it was losing. Okay, so you have data on the left hand side and you have insufficient data on the right hand side, and this is where they want us to find the electrons actually for gold, because if we know the number of electrons, then we would know even the number of the oxidation state or the oxidation number. So in the case of AG, we are having number of electrons being multiplied by the mass divided by the molar mass multiplied by Faraday's constant. So basically what we have just done here is that we have actually interpreted the N that is on top. So yeah, the number of electrons can be found by multiplying the number of electrons in the equation or in the stoichiometric ratio multiplied by mass over molar mass of the AG. So the same thing applies on the other side of the equation. So we're having the E being multiplied by the mass divided by the molar mass multiplied by Faraday's constant. Okay, so at this stage, since the Faraday's constant is the same, you can do well to cancel it because I don't like working with large numbers. Okay, so don't fall into the pitfall of trying to cancel the electrons. No, they're not equal. Neither are the masses equal. So yeah, we do the replacements now. So we've been given, and we said the electron for AG is 1, and the mass given for AG is 2.64 divided by 107 point let's say 0.6, no, 0.6. Let me just check it. Okay, it's 0.87. Okay, so let's make it 107.87. Okay, this is being equal to the E that we are looking for multiplied by the mass given for AU divided by the molar mass. Let me check the molar mass of AU. That's 196.97. Okay, 196.97. okay, so all in all, this is what we're having. Okay, this is what we're having. Then from there we just do simple mathematics and try to arrive at the answer. So basically, if we punch this through, we can just say that this one goes there, this one goes down here. Okay, so which means that on top we're going to have a 2.64 multiplied by 196.97, 196.97, everything being divided by 107.87 multiplied by 1.61, and this is going to be equivalent to the number of electrons. Okay, so let's just punch this in through on the calculator and see what we're going to have. So we're having a 2.64 being multiplied by, let me check, in 196.97, let me say equals, then divided by what was that? That was 107. Okay, 107.87 multiplied by 1.61. okay, so we're having a 2.99. okay, therefore 2.99 is equal to the electrons. Okay, so therefore E is actually equivalent to 3. Okay, so this is our final answer. So from the question, basically what we're saying is that the oxidation state of gold is actually 3.